Good day, everyone. For today, we will discuss the topic about pre-calculus, which is the last conic section, the hyperbola. So before we start, let us recall first the concept of the ellipse. As we all know, on the ellipse, there are different properties, and those properties will be carried on. Some will be carried on the hyperbola. So one concept is about the Pythagorean identity. So last time on the ellipse we have drawn a triangle or a triangle which includes the properties such as the covertex, vertex, and the foci. So for example, we have an ellipse in horizontal format and we have a center C. So we all know the distance between the center and the vertex is A units. So A stands for distance between the center and vertex. Okay, so we have that one. And then we also have the distance between the covertex, W sub 1, which is now represented by the B units. So B stands for the distance between the center and co-vertex. And lastly, we also have the value of letter C. So for letter C, it is not exactly in the middle or the midpoint between the center and the vertex, but rather it is right between those two. So we have what we call the F sub 1, which is representing the foci. And that distance will be covered by small letter C units. So C stands for distance between the center and foci. So we will get that and we will draw a triangle here. Again, center to covertex is B sub 1 or B units, sorry, W sub 1 for B units, and then center to the foci because it is shorter and it is closer to the center. It is represented by C units. When we discuss the ellipse, we have discussed that the distance between the covertex and the foci is equal to the distance between the center and the vertex. So it is represented by variable a. So for the Pythagorean identity of an ellipse, it is always a squared is equal to b squared plus c squared. Where when we are trying to find for the value of c squared, so we manipulate the given identity, it will become c squared is equal to a squared minus b squared. And then c is equal to the square root of a squared minus b squared. So that's the Pythagorean identity for our ellipse. So if you could still remember that the a or a value, this one, is equal to the distance between the center and the co-vertex. But how about on a hyperbola? For the hyperbola, we have properties such as focus and vertex that are being carried on. So if we draw a hyperbola horizontally, your vertex are on the hyperbola itself, v sub 1 and v sub 2. So the distance between those two is equal to 2a, where the center to the vertex is also a units and another a units. Okay? So a again stands for v1 to center. Okay, that's the meaning of variable a or a units. For the variable b, even though we do not have a covertex, we still represent the b as the distance between the center and our covertex. But for this hyperbola, there is an imaginary covertex. So that w sub 1 is still represented by the distance between the center and W1 is variable letter B. Okay, so that is still variable letter B, the distance between the imaginary co-vertex and our center. And lastly, the missing one is your focus. Focus is outside our hyperbola. So around here, F sub 1 and F sub 2. So as we can see, nagkabaliktad yung pwesto ni V1 and F1 mula kay ellipse. Si F1 na yung nasa labas at si V1 na yung nasa loob. So, instead of writing the Pythagorean identity in the format of center to co-vertex 1, it will be represented by the V sub 1 instead. So, hindi na F1. V1 na kasi siya na yung mas malapit kumpara sa ating foci. And in this concept, our distance between W1 and V1, which is the hypotenuse, will become your distance from equal na siya sa letter C na F1 to the center. So this C is center. So there's a difference between those two. So if C to W1 is B units and C to V1 is A units, the missing variable is the variable C. So on the hyperbola, your Pythagorean identity will become C is equal to A squared plus B squared. It's C squared is equal to A squared plus B squared. So if you are trying to manipulate or looking for the variable C, it is C is equal to the square root of A squared plus B squared. And this is the one that we will use to find for the variable C for our properties of the given hyperbola. Before we proceed to the properties of the hyperbola or getting the properties of the hyperbola, we should understand first what are the standard equations of a hyperbola and what is the format and what's the difference between an ellipse and the standard equation of it. So, let us go to this next slide. The first one is the horizontal hyperbola represented by x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1, where we can see that the first term of our numerator is being represented by the variable x minus h. So if your variable x is present on the first term of the numerator, so it indicates that your hyperbola is a horizontal hyperbola. And then a squared and b squared are on the first denominator and second denominator respectively, because in the concept of the ellipse, the denominators are being changed when it comes to the equation of a vertical. When we say ellipse, the first one is on the ellipse that is horizontal, it is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. This is for your ellipse. See the difference that for the horizontal ellipse, it is plus, and for the horizontal hyperbola, it is minus. But when it comes to the vertical hyperbola, the numerator changes. Still, a squared should be on the first term and b squared should be on the second term. So, if your vertical hyperbola is being shown as an equation, the standard equation should have y as your first term. In the concept of the ellipse, it becomes x minus h squared over b squared minus y minus k squared over a squared is equal to 1. The denominators are interchanged instead of the numerator. For the vertical hyperbola, the numerators are being interchanged. They are y minus k quantity squared over x minus h quantity squared, respectively for a squared and b squared. So that's the two standard equation of the hyperbola. So for now, we already know what is the difference between the standard equation of the hyperbola and the vertical one. So we can now find the standard equation given the different properties of it. So let us have the first example. The first one is what is the standard form of the equation of the hyperbola with the center at the origin and the transverse axis is on the x-axis, where A and B are given by 5 and 3. So let us write our given properties such as the center, the orientation of the transverse axis, the values of A and the value of B. So going to the next slide, it says that the center of your given is at the origin. It is important to know what are the values of H and K. But remember, one of the most important part of having the properties or the equation is the orientation. We can read that the orientation or the transverse axis, our TA, transverse axis, is on the x-axis. And as we all know, x-axis is the horizontal line on the Cartesian plane. And if the x-axis is horizontal, we can assume that the orientation of our hyperbola is in the format of a horizontal hyperbola. Okay? So we already have the center, the orientation. We can now give the equation that we need. It is x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So we already have the center, which is your h and k, 0, 0, but we need to find for the values of your a squared and b squared. For the values of a squared and b squared, we can read the given property on the question itself. And the given question is your a is equal to 5 and your b is equal to 3. So if a is equal to 5, and b is equal to 3, we can assume that a squared is equal to 25 and b is equal to 9. Then we can now input all our given properties. So on our standard equation, where x minus 0 squared over a squared, which is 25, minus y minus 0 squared over 9 is equal to 1. And then, we can now simplify the numerator where we can write or simplify x minus 0 as x squared over 25 minus y squared over 9 is equal to 1. And this is already your final answer. For our example number 2, it's the same concept with number 1. By reading our given, it says that we have an equation of hyperbola with the center at the origin and the transverse axis is still on the x-axis, and A is 6 and B is 8. As we can see here, this time the value of A is smaller or shorter than the value of your letter B. So this is an example of a hyperbola that is being shrunk as a horizontal one. Why I say it is a horizontal? Okay, so let us go to the next slide to show our properties. The first one is the orientation. It says that it is the transverse axis is still on the x-axis. And as we explained in number 1, transverse axis is on the x-axis and x-axis is horizontal. So, orientation natin ay horizontal hyperbola. So, we can assume our standard equation should be, again, in this format of x minus h squared over a squared plus, minus y minus k squared over b squared is equal to 1. Okay? And then number 2, it says that your center is at h and k. So if your center is at h and k and it is on the origin, it is 0, 0. And lastly, number 3 says that a is equal to 6 and your b value is equal to 8. So just like number 1, your hyperbola is horizontal, but the difference is your number 1 is taller compared to number 2, which is shorter horizontally. So that's the difference between the two, even though A for 1 is 5 and the B is 3. So A is larger for number 1, for number 2, B is larger or longer. So we can now write our final answer. It's in the format of x minus 0 squared over 6 squared. You can write that one, or you can write here that a squared is equal to 36 and b squared is equal to 64. So you can solve it first if you want. Y minus 0 squared over 64, diba? So ano yung 64 na yun? That's 8 squared is equal to 1. Your final answer would be x squared over 36 minus y squared over 64 is equal to 1. And this is your final answer. For number 3, we have now the center at 2, negative 1, and the transverse axis is given as a vertical. So, hindi na natin kailangang hanapin pa, i-analyze pa kung ano yung ating orientation. Binigay na niya sa number 3, which is vertical na transverse axis. And where B this time is equal to 8 and C is equal to 10. The struggle on this part is the center becomes at 2, negative 1. Hindi na siya sa origin, 'di ba? Then the value of a squared is missing. So to further analyze the problem, let us go to the next slide. So una natin titignan, binanggit na niya that the orientation of our given hyperbola is vertical, no? So vertical hyperbola. So we can now write our equation in the format of x, no? Vertical to, mga anak. This should be y minus k. So remember, hindi siya x minus h. It should be y minus k squared, where still a squared is on the denominator. Then x minus h squared over b squared is equal to 1 for your second term. So hindi na babago yung a squared and b squared, ha? Then number 2, binanggit din niya na yung center natin is at the 2, 1 coordinate. So, madali lang yan. Given na yung center, hindi na natin pa kailangang hanapin yung center, but rather, there's a missing part where we are trying to find for the value of our variable A. Bakit variable A? Sinabi niya dyan na yung value ng letter B units natin ay 8 at ang C ay 10. So, if B is equal to 8 and C is equal to 10, we can assume or we can say that B squared is equal to 64 and your C is equal to 100. Paano ngayon nahanapin yung letter A? Kasi nga kailangan natin yung letter A for our standard equation. We can use yung una nating diniscuss sa previous slides where we are trying to use the Pythagorean identity C squared is equal to A squared plus B squared. So, yun yung gagamitin natin ngayon. Sir, bakit po yan? C yung hinahanap dyan. Tandaan, C squared is given. So, we can input 100 is equal to A squared since siya yung missing plus 64 na value ni 8. So, 100, manipulating our equation to find the value of A squared. It's already A squared. So, 100 minus 64, that is 36 is equal to A squared. So, if you are asked what's the value of A, that is the time saka nyo lang kukunin yung square root. And that is positive 6. So, we already have the values of your A squared and B squared. We can now input our given A squared, B squared, the center on our standard equation. Remember, this is a vertical hyperbola. So, ang isusulat natin, instead of x minus h, it will become y minus k. And tandaan, k is the second number on our coordinate. which will become y plus 1 squared over a squared, which is 36 minus x minus 2 squared over 64 is equal to 1. Remember that negative 1 siya dahil y minus negative 1, may magkatabi tayong dalawang negative, lagi siya nagiging positive. Nagbabago tayo ng sign. And that is your final answer if your center is not on the origin. And last example for number 4. For number 4, let us determine the standard equation this time if the given are only the coordinates of the vertices and the foci. As we can see here, it's clear that it's 3, 1 and 11, 1 as your vertex. And the foci is at negative 3, 1 and 17, 1 as your F1 and F2. The problem is we do not have a center and the value of A squared and B squared. We only have the values of the coordinates for the vertices and foci. Let us recall first, how can we use these two given? Tandaan natin na ang definition ng center ay it is the midpoint of your hyperbola. So, mula pa lang doon sa definition na midpoint, so papasok na sa isip natin, pwede akong gumamit ng midpoint formula. 'Di ba? Pwede na akong gumamit ng midpoint formula to find the midpoint of our given, which would be our center. And then next, as we can see, the movement of the graph of this particular hyperbola. Going to the next slide, let us show that the movement of our given on number 4 is only horizontal. Why? So let us draw a Cartesian plane representing the given. So let's say this is the Cartesian plane. So we have 1, 2, sorry, it's being erased. 1, 2, 3. So 1 on the y. This is one of your coordinates, your 3, 1. Okay? So, another given is the other vertex, which is at 11, 1. So, on your 11, 1, it will move 8 units to the right. Why? 1, 2, 3, 4, 5, 6, 7, 8. Okay? 4, 5, 6, 7, 8, 9, 10, 11. This is already 11. Sorry, positive 11 instead of negative. And this is 3. So it moved or jumped from 3, 1 to 11, 1 as one of your vertices. It only moves to your right. Okay? That's your vertex 1 and vertex 2. So your V1 and V2 are moving left and right only, indicating that we have a horizontal hyperbola. At isa pa pong clue that the value of your y coordinate never changes. So on this particular problem, if your y value is the same, we can assume that it is horizontal hyperbola. And if your x values are the same, sorry, it should be r kasi marami, no? X values are the same, it is a vertical hyperbola. Ito natin siya. Yan. So, you have already the clue. You do not need to graph your given properties. So, if the two values of your y are the same, therefore, we can conclude that this is a horizontal hyperbola. And based on that, number 1 for us, this is a horizontal hyperbola having the equation x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And that is your standard equation. Okay? So, we can now go to the next slide to get now the solution for our center. The solution for our center, just like I mentioned on the previous slides, that we will use the midpoint formula based on the definition of a center. So, if the midpoint formula is given by x sub 1 plus x sub 2 over 2 for the x-coordinate and y sub 2, or rather y sub 1 plus y sub 2 over 2 for your midpoint. So we can use the coordinates of the given vertex or foci. So for the coordinates of the vertex, I will use v1 as 11, 1 and as my v2 as 3, 1. Okay? So let us check the formula again, that 1, 1 and 3, 1 on our given. Okay? So, if that's the solution, we will have my x sub 1 as 11 and my x sub 2 as 3. So, it will become 11 plus 3 over 2 and 1 plus 1 over 2. So, that would be 14 over 2 and 2 over 2. And the answer would be 7, 1. And this is already the center for our given hyperbola. So, hindi pa naman dito natatapos yung ating solution. For example, number 4, we also need to find for our a squared and b squared value. As we discussed previously, we say that the distance between the center and the vertex is a units. So, pwede nating mahanap yung a value by using the two coordinates of the center na meron tayong 7, 1 and vertex 1 na 11, minus 1. This time, since a units yung pinag-uusapan, gagamit tayo ng distance formula. For the distance formula, a is equal to the square root of, i-recall natin ang distance formula, it is x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So in this case, if your x sub 1 will be 7 and x sub 2 would be 11, you can write as 11 minus 7 squared plus 1 minus 1 squared. And that would be 11 minus 7, and that is 4 quantity squared. Then, hindi ko na isusulat yung 1 minus 1 because it's already 0. 1 minus 1 squared is 0 squared or simply 0. We can now cancel out the radical sign. And therefore, a is equal to 4. And we are looking for a squared. A squared, 4 squared is 16. And then, paano yung b? For the variable b, we do not have a covertex. But rather, the given is the foci. And one coordinate of the foci is at negative 3, 1. We can use 17, 1, but I will use this time yung negative 3, 1 as my other coordinates. So again, bakit yun yung gagamitin ko? Center is at 7, 1 and foci 2 as my negative 3, 1. Pinapakita ko lang na kahit 1 or 2 ang gamitin, pareho lang dapat kayo ng kalalabasang sagot for A and C. So for F2, I use negative 3, 1. So for the variable letter C, it is the square root of 7 minus negative 3. It will become positive 3 squared plus 1 minus 1 squared. And then we will have 7 plus 3, 10 squared. Same with the variable a. If 1 minus 1 is 0, so we do not write it already. And then, therefore, we can now cancel the radical sign or the root symbol and the squared symbol. And the value of c is equal to 10. And if c is equal to 10, we can say that c squared is equal to 100. And that 100 will help us to determine our standard equation because we can use the c squared in the Pythagorean identity. C squared is equal to a squared plus b squared, where a squared is equal to 16 and your c squared is 100. Then manipulating on our given, we can now transpose or move 16 to the left side of the equation. 100 minus 16 is equal to b squared. So 100 minus 16 is equal to 84 is equal to b squared. And then we can now write our standard equation where x minus 7 squared over a squared, which is 16, minus y minus 1 squared over 84 is equal to 1. So that is how you solve a given equation of a circle of a hyperbola where the only properties present are the vertex and the foci. So that's all for our first video. On to the next one.